Hi friends, welcome to this YouTube channel. Today I am going to discuss a problem which came in December 2019 CSIR NET exam. Exam was held on 15th of the month and this question was a 5 marks question from part C. So relatively it was very easy question but few candidates attempted it wrongly. So let me explain that. The question was the outermost shell of an atom of an element is given, which is 3D3, and they were asking to find out the spectral symbol for the ground state. Now, before attempting the question, you should know the concept of orbital and subshell, or what you say, the subdivision of the shell, right? A shell is divided into different subshells, and a subshell is divided into different orbitals. Each subshell have at least one or more than one orbitals. So because in this question it was given that the outermost shell of an atom is 3D3, so we are only considered with the D subshell. But let me explain what subshell is. There are different subshells like S subshell, P subshell, D subshell, F subshell, G subshell, H subshell, and so on. All these subshells have different L values. What is L? L is the orbital angular momentum, or you can say it's azimuthal quantum number that represents different subshells. So S subshell have L value 0, P have the L value 1, D 2, and F have the L value 3, right? So these are different subshells with different L values. Now because the outermost shell is 3D3, so we are only considered with the D subshell. Let me draw the D subshell. It have 5 orbitals, as you know, so you will draw it like this. Now you need to do the filling. Of the orbitals, because the outermost shell have 3 electrons only, as mentioned here. 3D3 means the outermost shell of an atom have the subshell which have 3 electrons, and this is the subshell. So I'll do the filling of electrons like this, right? All these electrons should be parallel, and I'm not doing the pairing of these orbitals because according to the Hund's rule we know that the electron prefers to remain unpaired as far as possible, and also electron in a subshell will be paired only when all the orbitals of a subshell is half filled with parallel spin. Got it? So filling would be done like this. Now we need to calculate the overall spin value, overall L value, and by that we will find out the overall J value for this. Now how you will calculate the overall L value? First of all, you should know the magnetic quantum number ml for all the orbitals. ml is the magnetic quantum number that represents the possible states, or you can say possible wave functions, and it have the value from minus L to L. As I told you that D subshell have L value 2, that means ml for all these orbitals in the D subshell would be minus 2 to 2, which is minus 2, minus 1, 0, 1 and 2. So I write down the ml values here for these orbitals. It would be 2, 1, 0, minus 1 and minus 2. Now you need to calculate the summation of these ml values, or you can say the modulus of summation of ml values. What would be that? 2 plus 1 plus 0, which is 3. Why I have not taken minus 1 and minus 2? Because electrons are not filled in these orbitals. These orbitals are empty. That's why I have taken only these 3 orbitals for the consideration of the L value. So that means overall orbital angular momentum would also be 3. Now you need to find out the overall spin value S. What would be that? Because all these 3 are parallel, so it's half plus half plus half. That means overall S would be 3 by 2. Now you know overall L, you know overall S, so you can calculate overall J value. Overall J value would be L plus S, or you can say L minus S modulus to L plus S modulus, which is what? 3 minus 3 by 2 to 3 plus 3 by 2. So it is 3 by 2 to 9 by 2. So all the j values are 3 by 2, 5 by 2, 7 by 2 and 9 by 2. Right. Now which j value you need to consider? For that you need to apply the Hund's rule once again. Hund's rule states that there are two major points of Hund's rule. Hund's rule says that you need to consider the j value, the maximum j value, when the subshell is filled more than half. Right? So you will consider maximum j value when subshell will be filled more than half. If the subshell is less than half, then you need to calculate the minimum j value. Okay, now here you can see that the maximum number of electrons that can completely fill the d subshell is 10, and we only have 3 electrons to fill this d subshell. That means it's less than half, right? It is filled less than half. So we need to consider the second point, that we need to take the minimum j value from all the j values, because the subshell is filled less than half. So we will take the value 3 by 2, not 9 by 2. Let me take the second case. If the subshell was filled more than half, then we had to take 9 by 2. If there were more than 5 electrons to fill in the subshell, then we can take 9 by 2. But here, because it's less than half, so we are considering 3 by 2. Okay, so we have the j value 3 by 2. Now what is the term symbol? Term symbol for the ground state. They are asking term symbol for the ground state. So what we will do, it's 2s plus 1 L j. Right? 2s plus 1 is the multiplicity. We know the overall s value, so we can calculate 2s plus 1. It would be 4, and the j value we have found is 3 by 2. So we can easily write down the term symbol, which is 2s plus 1 is 4. The overall L value is 3. That means we need to take F in place of L. So it's 4F, and the j value is 3 by 2. So it's 4F 3 by 2. This is the term symbol for the ground state that they are looking for. So the answer is option A, 4F 3 by 2. Right? I hope you like the video. If it was helpful for you, so you can subscribe this channel, and I'll upload more videos in the organized way for all the exams like CSR, NetGate, JEST, and many more. Okay, thank you so much.